Today we will see one interesting problem, problem 5.23 of Griffith 4th edition Introduction to Electrodynamics. The problem 5.23 is find the magnetic vector potential of a finite segment of a straight wire carrying a current I. Put the wire on z-axis from Z1 to Z2. See, I will explain this graph, this plot. That is, this is distance along the y direction. Let's say along the y direction. This is Z. So let us say this is R. This is R, distance R. So here, this point is Z1. Let us take this point is Z1 and this point is Z2. So this distance is yes. Let us say this distance is yes. So then what is this R? R is equal to Z squared. There are 2 points, whatever may be, the general formula is for R to find the R. Square root of s squared plus z squared. So the for a magnetic vector potential is defined as mu naught over 4 pi integral 1 over script r z cat, because we are considering along z direction, 1 over script r z cat t z. So this r can be written as I said, s squared plus z squared square root of z squared plus s squared dz. So along the of course along this z direction z cat. So now you take the constant outside. Already we have taken the constant outside mu naught I 4 pi z cat. So now we are in integrating between the point z1 and z2. Z1 and z2 is small wire segment as mentioned in our problem. So we are differentiating with respect to, sorry, integrating with respect to tz. If we integrate 1 over square root of z squared plus s squared, then we have seen this in problem 2.25. Kindly refer my problem 2.25. I have given the link in the description box. So the integral of 1 over square root of z squared plus s squared is equal to natural logarithm of z plus square root of z squared plus s squared. Here the z is variable, so within the square root the variable is z. So z normal, easy to remember that this integration natural logarithm of z, that is variable, plus square root of z squared plus s squared between the limit z1 and z2. So if you apply this limit, this z upper limit is z2. So this will become z2 plus natural logarithm of z2 plus square root of z2 squared plus s squared. If you apply the lower limit minus natural logarithm of z1 plus square root of z1 squared plus s squared. We will try to simplify this as much as possible. So we got this magnetic vector potential A is equal to mu naught times I divided by 4 pi z cat, natural logarithm of z1 plus square, sorry, this is z2 plus square root of z2 squared plus s squared minus z1 plus square root of z1 squared plus s squared. So if you simplify this negative natural logarithm will become into the denominator like this. So z1 In the denominator, you will get z1 plus square root of z1 squared plus s squared. Now, the magnetic field is equal to the curl of the vector potential A. So, the in a cylindrical coordinate, because we are taking a straight wire, so the Amperian loop is cylindrical in shape. So, in cylindrical coordinate system, curl is equal to minus partial derivative of the vector potential A with respect to Ts. That is with respect to S. So, of course, we have taken this constant outside, mu naught I over 4 pi epsilon. And we are going to differentiate this natural logarithmic term. Here, for mathematical convenience, I am rewriting this square root as power of. Here also it's power of. So, now if you differentiate this, that is t by tx of natural logarithm x is equal to 1 over x. It's a standard differentiation. So if you differentiate this, the entire thing will become to the denominator, which is equal to 1 over z plus square root of z squared, z2 squared plus s squared. So this I am taking this 1 over x, this as it is. This term I am taking as square root of. So again, we have to differentiate with respect to s, because here you have a term s squared. So if you differentiate this, then you will get uh, z of that is 1 over 2 of uh, z squared plus s squared minus half, because you have to subtract by 1, sorry, minus 1. So half minus 1 become minus half, which will become minus half. So this is square root 1 over square root of z2 squared plus s squared. And if you differentiate this term with respect to s, if you differentiate first term, this will become 0. This is also will become 0. Then s squared will become 2s. So here I have written 2s. Same thing is here. Differentiation of natural logarithm of x is 1 over x. Then again you differentiate this with respect to s. So this will become 0. This term also will become 0. And this will become 2s. Of course, you have to subtract 1 minus 1. So this will become entire thing z1 squared plus s squared minus half. This will become minus half. So minus half I am taking in the square root in the denominator. This will become in the denominator square root of z1 squared plus s squared. Here 2 will get cancelled. Here also 2 will get cancelled. So you can take s outside. I am taking s outside. So inside the bracket you will get 1 over z2 plus square root of z2 squared plus s squared. Then because I have taken s outside, 1 over square root of z2 squared plus s squared. Same thing is here. This is along pi direction, pi cat. So unit vector along the pi direction, because this is magnetic field is perpendicular to the current applied, so it is along the direction pi cat. Now we got the magnetic field is equal to minus mu naught I s over 4 pi, and multiplied by 1 over z2 plus square root of z2 squared plus s squared, multiplied by 1 over square root of z2 squared plus s squared. Same thing here, pi cat. Now I want to simplify this first term, this term. Then similarly I will apply here. So I am taking 1 over z2 plus square root of z2 squared plus s squared. What I am going to do is I am going to multiply this by multiply and divide by z2 minus square root of z2 squared plus s squared. So I am dividing by same thing z2 minus square root of z2 squared plus s squared. So this is equal to uh, as I discussed in problem 2.25, it is equal to a plus b into a minus b. See, let us say this z2 is a, this square root term is b, then this is a plus b, this is a minus b. So a plus b, a minus b is equal to a squared minus b squared. You know, it's a well-known formula. It's equal to a squared minus b squared. So a squared means here z2 is a, z2 squared minus b squared. B squared is this term. So this is square root will get removed. So this will become minus z2 squared, then minus of minus, minus s squared. This will become minus s squared. Here you can notice that z2 squared minus z2 squared will become 0. So this will get cancelled out. So we will get only the denominator and sorry, in the denominator you will get only minus s squared. In the numerator you have z2 minus square root of z2 squared plus s squared. So you can replace, it can be replaced for this one. So you can replace, I will use different color. You can replace this for this term. So if you replace this, you will get z2 minus square root of z2 squared plus s squared divided by minus s squared, this term. And of course, you have this 1 over z2 squared plus s squared. Apply the same thing for this term. That is, I'll use still different color. This term, that is this. So here instead of Z2, you will get Z1. That's all. This is equal to minus Z1 minus square root of Z1 squared plus S squared divided by minus S squared. The second term will come as it is 1 over square root of Z1 squared plus S squared pi cat. Now what I am going to do is I will take this S squared, which will cancel out with this yes. Here you have yes, so this s squared will get cancelled and this s squared will cancel. Simply it will become yes, and this minus minus, here one minus will become plus. So this will become mu naught I over 4 pi. I am bringing this s outside. In both term, s is in the denominator, so I am bringing that to the denominator. Then I will rewrite this as z2 minus square root of z2 squared plus s squared divided by z2 squared plus s squared minus this term z1 minus square root of z1 squared plus s squared divided by z1 squared plus s squared. This is the magnetic field. We can reduce still further. Now we got the relation for the magnetic field, which is equal to mu naught time I divided by 4 pi s multiplied by z2 minus z2 squared plus s squared divided by z2 squared plus s squared. Same thing with z1. z2 is replaced by z1. Now we can rewrite it, separate this term, each term into two parts. First term, you take Z2 and denominator, then minus this z2 square root of z2 square plus s square divided by this denominator. Same thing with this. First you take z1 and denominator as it is. Then minus of minus will become plus. Then the second part, square root of z1 square plus s square divided by square root of z1 square plus s square. Now, this term you can see this is minus 1 because numerator and denominator are the same. This is plus 1. So, both will get cancelled. That is second and third, second and fourth term will get cancelled. You will get first and third term. First term is z2 divided by square root of z2 square plus s square minus z1 divided by z1 square plus s square pi cat. Now we will see what is this first term and second term. First you take this distance. We have seen this distance is yes. This is yes, and this is z1. This distance is z1. So naturally, this distance is z1 squared. Sorry, z1 squared plus s squared. So let us say this is theta 1. By termination, what is theta 1? Theta 1 is equal to z1 opposite side to hypotenuse. That is z1 divided by z1 squared plus s squared. So this is equal to sine theta 1. The second term is sine theta 1. Now you will come to the first one. First one, let us say this distance is z2. Maybe I will use different color. So this is S only. So what is this distance is equal to square root of Z2 square plus this S square, S square plus S square. Let us say this is theta 2. Then what is theta 2? Theta 2 is equal to opposite side, that is Z2 divided by this one. Hypotenuse, that is square root of Z2 z2 squared plus s squared. That is this one. This one is equal to sine theta 2. So this is exactly this expression exactly represents the Biot-Savart law for a straight wire. Biot-Savart law. So it's a really interesting thing. Biot-Savart law. Thank you very much for watching my video and supporting me continuously. Thank you very much.